So our first slide here that I think we're all looking at now, or we've moved on, is asking which of these areas is bigger or are they equal? And if I use my draw tool, what could I draw from the middle of this guy? Okay, just checking that I am recording. Yeah, so I can definitely draw a 4. Can anyone talk me through what else you maybe did to help you compare? So I know B is at least 4. Zane?
So I see that the triangles on the ends of the B shape both have half squares, and there's 4 sides, so that's 4 additional squares.
So do you see, like Zane sees, that if I move this half square, or we could call that a triangle, right, over to there, it'd be a square. That's going to help us on a lot more slides than just the first one. Raiden, what are you doing, sir? No, you're not. Put it down. Put it down. You do not need a ruler for this.
There's a straight line tool.
That is not necessary.
Oh, yeah.
Yeah, a ruler is not necessary, bud. Yeah, sorry, but I want to make sure we all agree. So wait. Hey guys, stop talking for a moment. So we know there's 4 here, right, in the middle. But then Zane told us, because I drew on it. Thank you. Zane told us if I put these together, it's another how much? 1, 1, 1, 1. So I've got 1, 2, 3, 4. 1, 2, 3, 4. So this is 8. It looks the same. Like in my brain, I'm like, yeah, those squares pretty much look the same size. They look the same size, but they're not. B is actually only 8, whereas A is actually 9. Right? All right, keep going then. Unsync. Sophia, really?
What? What?
Keep moving on, Sophia.
Well, I still need to click in.
Yeah, maybe if you wouldn't take so much time drawing a heart.
Okay, well, it has to be pretty.
You have to admit it was hard. The world needs more love. Someone write a song about that?
What the world needs now is love, sweet love. Victor says these two are equal to each other. We're going to come back together and chat once we've all made it past talking to Victor. You literally just said A is 9 and B is 8.
I know. I was going to show you. These two make one.
Dig it? Is what, right? Well, 1, 2, 3, yeah, so you're meaning the middle's 8. And then another. Oh, yeah. Do you remember what the title is? I mean, I could just search up, like, what the world needs now.
Oh. Yeah, it's just what the world needs now. Why that needs
So the top result, Emery, is actually by a dude named Burt Bacharach. Well, I'm just looking on Spotify, like what's coming up. Hey, actually, never mind. I'll announce that in a minute. Devin, why'd you skip over a couple slides?
Devin. Oh, not good.
I said that one. Oops, never mind. I clicked twice apparently. And I need
All right, I need some help. Hey, I will unsync us after we talk about this. Emery, tell me what you did to start, but don't tell me the whole thing.
Okay, so the first thing I did, I figured out what the ends were, like the non-middle part.
The non-middle part is where you started. Interesting. So, okay, you're meaning draw like the non-middle part?
Yeah.
Okay, so what'd you figure out with that?
Well, I figured out that one of those little ends together equals one square. But if you wanted to put the two
So if you don't believe Emery, if I draw this using two different colors, and then I grab that, flip it around, move it up here, I think Emery's onto something. That these two together. Now also guys, I could use my area of a triangle. Hey, please don't make me pause the activity. That makes it feel silly that I have to make you stop looking at something. If we want to talk about the area of a triangle, this is going to be necessary in the next activity, Matt. The area of this triangle, we said area of a triangle is half the base times the height. So if I look at this base, I'm going to write on this one because the blue shows up a bit better. We've got 1 and 2. So 2 times 1, but then half of that, that's evidence that what Emery said is true, that each of these is 1. Right? So we've got 1, 2, 3, 4. And then Lane, what'd you do after, if Emery started with the wings, what else do we have? Yeah. So 8 plus the 4 that Emery found, what are we getting for our total? 12. So then Victor says, you know, this shape's actually the same as that shape when we're talking area. Is Victor right? Yeah, he is. Brilliant. You can subdivide, right? That's what we call, you can subdivide the shape. What do you mean? So how else could you break these shapes? Ooh, wait. If you go back to the first line that you drew, sorry, I need to anonymize. Go back. Click back. So Emery, I'm looking at your screen. This was the first line that you drew, right? If we just draw that line, what shape do we see on the bottom? Yeah. So just like Lane was saying with breaking things up into different ways, you could also break this up into 2 trapezoids. Yeah, see, when you zoom out a little bit, it lets us see things differently. Let's, for sake of time, sorry friends, but I'm going to yank you up to slide 6. I am so sorry. Which has more area, C or D? Then I want you to keep moving on to slide 7. It's okay if you ended up skipping some slides, but I want you to take a moment to think about this, move on to slide 7. Ooh, love this. Crap, so I gotta click anonymize first. Alright, so someone's doing this, and they cut this up. Is this little square here 1 or less than 1? It's less than 1, right? And this little square on the edge too, I mean, not square, really, if I'm being technical. None of these are squares, because the curve. Interesting. Okay, how many can I see? Okay. How many are, you do a rectangle around, how big would that rectangle be? Okay, so keep thinking through this slide and then you might change your mind. So in my brain, I did this, right? When I looked at this, I did this. I looked at this and I did that. Right? I looked at this, I did that. So, Raiden, if I draw this rectangle around Eli, if I draw this rectangle around D, how big would that rectangle be? Like this rectangle around D. That rectangle would be 8. So what do we know about D? Is it more than 8 or less than 8?
Less than 8.
It's going to be less than 8. Who got pizza last night for the fundraiser? Nobody? We had Porch Growler and Pizza Primo fundraiser. So here's the only reason Pizza Primo doesn't quite work with what we're about to talk about. We're going to talk about rearranging your leftover pizza, but Pizza Primo cuts in rectangles, right? We're going to think about triangle pizza slices. So what I would like, we might come back to area strategies, but right now everyone hop out of area strategies and go to Y pie. Y pie. Skip over to Y pie. Oh, I did not assign it yet. Sorry. It's there now. Oh, Tom Jones. Tom Jones. So guys, you are switching over to Y pie. If you are still in area strategies, please switch over to Y pie. Gonna run out of patience. Lane, Matt, I know Raiden's not in the lane now. I see you there. Matt, you getting in?
Yeah.
There we go. I was waiting for Desmos to show me that you've arrived. Raiden, we switched over to Y pie. Different activity. Still Desmos, but different activity. Y pie. Hey guys, do you need different seats? Because it really feels like there's too much, like, I don't even know what's going on, but there's too much. And I feel like there'd be less of it if you weren't sitting next to each other. So you tell me, can you sit next to each other or do you need to be apart? Then show me that you can get into the activity and get going. It doesn't really take interacting with each other. So I don't know about you, but if the first slide showed me a circle with a radius of 5, then when I go to my second slide, I'm probably just going to make this radius 5 so I can think about the first slide. Now, if you left it as a radius of 1, obviously you'd have less to count. But if I make it a radius of 5, can anybody tell me what I could do to start figuring out like an estimate for this area? Jack, what do you think? Okay, but how? If we don't know formulas yet, and I know some of you have looked at the whiteboard and you've seen it, what do you think?
So multiply the radius.
Well, if we don't know the formula, we could break this up, right? So we could start breaking this apart, but don't take too long on this slide. Break it up if you want to, just make an estimate, but then move on. Because then, and this is why I love Desmos, it's going to take the circle apart in a really interesting way. It's going to cut the circle up into like little ribbons. So don't take too long on this slide. You can break it up into rectangles if you want to. You could count every single individual square and all. Now, you don't have to do a radius of 5. That's just what I probably would have done. What's up? Hmm? Yeah. No, you're fine. I mean, I'm going to give you a handout before you leave anyways, so. Yeah, you'll have formulas before you leave.
Okay, thank you.
You are welcome. So then slide 2 is going to show us this. Interesting.
Slide 3.
Slide 3, yeah, okay, slide 3. Matt, you need one of these too. Because you weren't here during class yesterday. This slide asks us, and now we're all looking at it. Sophia. This slide asks us, do we think this is a proportional relationship?
No.
Why are you thinking no?
It doesn't start at the origin.
If I connect, wait a minute. Is this even a straight line? No! And beyond that, what Sophia said, absolutely true. Even if I try to make it a straight line, it doesn't start at the origin. So friends, everybody who had moved past this slide currently had it wrong. This is not a proportional relationship. 1, it's not a straight line. And 2, even if it was, it doesn't start at the origin. Thank you. I'm pretty sure, but I mean, there could have been a moment between me like looking at the screen and getting up there where you moved on. It doesn't tell me like a check or an X until you've moved on. So guys, again, here anonymized, but here's my view, right? And it's okay that a lot of us got the first slide wrong because we didn't quite know what we were doing. But slide 3, now I kind of care that we actually realize, no, this is not proportional, because if I try to use my straight line tool, right, and you can do this within Desmos, I can see it's not actually a straight line. Especially now we've got a new point here. Definitely not a straight line. This feels like a curve. Feels like some sort of curve. space inside of it. We are learning, we learn right now. Area is how much pizza you've actually got. The circumference would be like the crust around the pizza. Diameter is essentially how big the pizza box is. Yeah, we're quote unquote in chapter 9 right now. Even though I abandoned the textbook for the current time.
Wait, what about chapter 8?
We already did chapter 8. I just gave you guys individual notes about that. We took notes right here, you guys, those papers. This isn't even all of the chapter 9 notes. It's just what's important right now. I was waiting for Emery to get back to talk about these notes. I mean, you can. It's just inconvenient timing. So, I mean, it's up to you. Class is over in like 12 minutes. Bless you. All right, so hopefully, and if you haven't made it to slide 4, let's go on up to slide 4. There's a couple of us hanging out back there. When we unroll it, interesting.
Very satisfying.
When I know, right? So wait, so the outer ring, like the outer ribbon, unrolls flat to the bottom. What does this kind of look like?
Pyramid.
Kind of looks like a pyramid, but because it's flat, we would actually call it, what sort of shape, like 2D shape does it look like?
Triangle.
It looks like a triangle, guys. So what we're thinking is, okay, we need to relate this to a triangle. This circle became that triangle, relatively, right? It cut it up and unrolled it. And then I made more rings, so it stacks a little tighter. But guys, the bottom, the base of this, how big was the base of it? Well, it was how big the circle was around. What's how big the circle is around? Hey guys, my whiteboard's all new. Put a ton of time and effort. Matt saw me up here on like my knees so I could write the stuff at the bottom. Like,
So use this like a cutout circle too.
so, what we're talking about here is how do we find the area, right? And if we turn it into a triangle, the base, and if you move on to the next slide, you'll see this. The base is 6 pi because it's the circumference. That outer ring puts the circumference on the bottom. Good, I could not wait for long. You only missed like 30 seconds of this. So when we unroll that circle, the circumference is the bottom. But where did this height come from? Where did the height of the triangle come from? Sophia?
Never mind.
Where did this, they tell us it's 3. Where did that come from?
Oh, we know.
Sophia?
It's from the bottom of like the circle to the middle.
That is our radius. Right? So that height came from our radius. So keep going. So remember, for triangle, we got to do base times height, divide that by 2. Right, we got to do base times height, divide that by 2. Jackson, that's trash now. That won't be the schedule next week. It only mattered for 2 days. I do base times height, half of that. I really just wanted to get your attention for a second. The triangle area, base times height, then divide that by 2. What's my base? 6 pi. Guys, did they convert pi to 3.14? No. You can. We are allowed to work in terms of pi. Hey, Matt, you are totally not paying attention right now. It's really obvious. When we're working in terms of pi, you leave pi as pi. We could convert to 3.14. We could do the math. They just left pi as pi. So if we leave pi as pi, what's 6 pi times 3? 18 pi. What's half of that? 9 pi. You could just type in 9 pi, and literally, if you type pi, it switches it to the pi symbol. So if you type 9 pi, as soon as you hit the I, it switches to the pi symbol. Or you could do the multiplication, and what's 9 pi equal to? 28.27. Sure, yeah, so if you want to do the math, or you could just do 9 pi. Okay, for sake of time, everyone come to slide 8. And by everyone come, I mean, hey, join me. So, let's click rearrange on your pizza. So this is a pizza. You're trying to put the leftovers away, but unfortunately, and I don't know if you guys have ever had this happen, when the pizza driver was bringing the pizza, the box got all wet. So, you know, mom or dad or whoever are like, all right, we got to throw the box away. We're going to rearrange the pizza. So you have this on your screen. We're going to rearrange the pizza. Oh, hey, if I put some of the slices up and some of the... What's this more similar to now? What shape is it closer to? A rectangle. Well, yeah, really a rhombus if we want to be technical. But it kind of looks like a rectangle. Now slide this to more slices. Maybe you decide we're going to cut the pizza up into extra slices so we have more leftovers.
It gets like more like a
It gets more and more and more rectangular. Look at the math notes I put at your table. Oh, hey, it would be convenient if I actually plug in my dot cam. Look at the part that says area of a circle while I fight with my dot cam. All right, check it. Here's our pizza. Now, friends, I'm sorry I don't have the budget to print everything in color, but here's our pizza. If it would help you to have each slice a different color, like look at that, but honestly, I can show you this through my smartboard too, but these are the notes that you have. Why the formula becomes what it becomes is when we take that pizza, lay it out, rearrange it. I only have half of my slices pointing up, and half of my slices are pointing down. So this length across here is half of the circumference. Now the circumference we talked about yesterday being pi times diameter. But diameter is also 2 times the radius. So circumference can also be written as pi times 2 times the radius. It's just a bit more complex. It's more to write. So that's why I normally don't teach that to you guys. But look at your paper up at the top part where it says circumference. You have both of those formulas. Radius. Stop. So if we do half of that, half of the circumference across here, well, really, I can just divide by that 2 is going to cancel out, and we just get pi times r. So now that we've made this into essentially a rectangle, how do we find the area of a rectangle? Base times height. And that's what leads us to the formula that's on your paper and is up here. To find the area of a circle, we do radius squared times pi. Now, if you want to try to prove this in different ways, that's where we can keep working through that Desmos. And you are always welcome to come back to Desmoses outside of class. But if you go through and you look at the different, if we reset this and rearrange it, it makes sense. It turns into a rectangle. The bottom is half the circumference, pi times r, and the height is r. I mean, you don't really have time because I needed to make sure that I got this taught to you guys. Also, tomorrow we will be in here all of block 1. We're going to take your practice test during block 1, and then I'm not meaning to show that. Sorry, meant for that to be on LearnStorm. And then we will do a bit more like mathy stuff. But then I'm going to trade that time back to Mr. Estes next week when you guys are finally working on writing your essays. So, like, you'll have extra math time this week, extra connections time next week. We are losing by a ring. Right, 3A. Right, some has an 81%. And really what it comes down to is they have a different number of kids in their class. So, do you guys think...
Not anymore.
You think we'll make it 1%?
Actually, yeah, because I completed the rest.
Do you think we'll fill this ring?
Yeah.
All right, here we go. Oh, do you think we'll fill ring 7? You guys made it like 3 rings yesterday. All right, let's check. Oh, 20%, 30%, 40%, 50%, 60, 70.
It stops.
It could go all the way. All right, how far do you think in ring 8?
Not that far.
Let's see. Let's see what happens.
Oh my god!
You don't actually have a
30, 40, 50, 60. I think some people did their homework. There you guys go. Keep going. Keep climbing. Have a great day. I really can't answer any questions right now because I realize I'm not ready for my next class. Sorry, I really gotta like finish prepping.